let's use this organic compound. This is an example of alkane organic compound since all these skeletal structures contain only carbon-carbon single bond. Now, the first thing to name an alkane organic compound is to get the longest continuous carbon chain. From here, we can see that if we start from here, we have 1, 2, 3, 4, 5, 6, 7. Perhaps this is the longest continuous carbon chain we have here. Hence, you can say that our roots will be what? 7. When we say roots, in organic nomenclature, we have to do something called the prefix plus the root plus the suffix. These three makes up the organic nomenclature, the aliphatic nomenclature. Hence, we have to get our roots. The root is just telling us the number of, like, the longest continuous carbon chain there. The suffix is telling us the functional group that will be the parent's name. You understand? And if you check here, we've gotten our root at 7, the longest continuous carbon chain. If you check this compound, the suffix is going to be alkane. The suffix there is going to be ane. If you check your concept of English, you know that whenever we have something like this hyphen, then we write D, then that's more of like suffix. And that's the same concept here. Suffix, then we have A. So that's the same concept. Now, prefix are those substituents that are attached to the longest continuous carbon chain. And we have our longest continuous carbon chain as from here to there like this. Hence, we can say what are the substituents attached to this longest continuous carbon chain. We have at carbon 4, we have this man here, and at carbon 5, we have this man here. Actually, we have to do forward and backward numbering. So to actually give it which one you have the lowest carbon atom. So if we start the backward numbering from there, say 1, 2, 3, 4, 5, 6, 7. Now, if we consider the forward numbering, we have the first, this substituent here, and this man here, this substituent here attached to carbon 3 and carbon. Check out this substituent here. Why this substituent here is attached to the one that looks like this, the one that looks like this is attached to the, it's just attached to carbon 4 and carbon 4. Now, if you have to consider the backward numbering, the backward numbering, this is it here, and the forward numbering, this is it here. Hence, you can consider the backward numbering. That's what we have to consider here, because it gives the lowest carbon atom, you know, for the substituent. So now, how do we know the substituent? This substituent here, which is the first thing we are considering. This substituent here, whenever you see anything like Y, whenever you see anything like Y, it simply means what? Isopropyl. Whenever you say anything like Y, it simply means isopropyl. That's all these things, and all these things are just called alkyl pattern. They are substituents. But in skeletal structure, we just put them because they are like substituents that has a particular pattern. So whenever we see like a Y pattern is isopropyl, and whenever we see this pattern, that this is the longest continuous carbon chain here, and this is also the longest continuous carbon chain here. This is what seg-butyl here. Seg-butyl. Why is this seg-butyl? Because the carbon that acts as the point of attachment is connected to two other carbon. And whenever we have secondary in chemistry, whenever we say a carbon is secondary, that is it's connected to two other carbon atoms. So that's how to know it. So just know the structural pattern and the like alkyl pattern. So whenever you see this pattern and the substituent, you know it. So now since we can identify the substituent, now the next thing is to get where are they attached to what carbon atom? Isopropyl here. The isopropyl is attached to the carbon 3, considering the backward numbering. So it is attached to the carbon 3 and the seg-butyl. We have the seg-butyl there is attached to the carbon 4. So since getting our substituent as isopropyl and the seg-butyl, then the next thing is to get our prefixes. And we know that our previous is just our substituent. Now, the first thing, how do we arrange it alphabetically? You have to know that we are talking about alkyl patterns. We are talking about sec, iso, cyclo, and neo. You have to know that when it comes to IUPAC nomenclature and we consider something alphabetically, we have that we are considering only cyclo, we are considering also iso and the neo. So anything apart from this man here, we are not considering them in the alphabetic order. Understand? Why naming? Hence, we are not considering this sec here. We are going to consider the B for this butyl. Hence, this butyl has to come first. This butyl has to come first. That's just the logic. But we are considering this I here. So that's just the logic that we are considering only these three kinds of alkyl patterns. That's why the sec, we are not considering this S here, we are considering this T here, and we are considering this I here. Hence, sec-butyl comes first. So the sec-butyl is attached to the carbon 4 based on the backward number. That's 4 sec-butyl. Then, if we are, the second substituent we have here is the isopropyl. The isopropyl is attached to the carbon 3. That's like 3 isopropyl. Then the next thing, we've gotten our prefixes, our suffix, and our roots. How do we now get our IUPAC nomenclature? So we know that IUPAC nomenclature is just prefix plus root plus suffix. We just have to now write, where's our prefix here? 4 sec-butyl, 3 isopropyl. Then if we have that the IUPAC nomenclature, the IUPAC is 4 sec-butyl. Then we have -3 isopropyl. Then what's the next thing? Plus the root. You are not going to be doing something plus. You are just going to write it. That what's the root here? 7. And for 7 now, we are going to write in words. 7 is x. Just like 1 is met, 2 is x, 3 is proof. So 7 is x. So we have something like this. When you write this, the next thing is root, so we have x. Now, the suffix here is a. That's why you have this hyphen before the n. So you just don't put your a. And that's how the IUPAC, we name this kind of compound that 4 sec-butyl, 3 isopropyl, okay. Following this normal formula for writing the IUPAC nomenclature. That's all.